Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We are from Group 1 and we are from Section 01D. Also, our case study is Easybook. Let me introduce you to my group members. I am the project manager of this case study. My name is Nabil Niafaki bin Faisal. My metric ID is CB250100. And our system analyst is Muhammad Daniel Hazim bin Zainuddin. The metric ID is CB25069. And our programmer Muhammad Aidid bin Muhammad Mohar, CB25099. And our tester Aisyah Maisara binti Muhammad Radwan, CB25059. Easybook is one of the leading online travel booking platform in Southeast Asia, providing services for buses, trains, ferries, car rentals, and tours. It was developed to simplify travel planning by bringing multiple transportation options into one easy-to-use website. With a platform like Easybook, travelers often face challenges such as long queues at ticket counters, limited access to route information, and difficulty comparing prices and schedules. Easybook addresses these issues by allowing users to search routes, select seats, make secure online payments, and receive instant booking confirmation. Through partnership with many transport operators across the region, Easybook offers a convenient, reliable, and transparent solution that improves the overall travel experience for both local and international travelers. So this is the screen capture of main user interface. As you can see, there is the bus ticket, ferry ticket, and train ticket. Managing system complexity. Easybook uses a layered system to make things simple and organized. The top layer handles what users see, like search filters and seat selection. The next layer connects user to the back end. The business logic layer keeps the rules like ticket pricing and refund separate. The data layer talks to the database and payments gateways. This way, each part can be developed, tested, and updated independently, making the system easier to maintain. Reservation and booking services. This service manages the logic for booking seats and gathering passenger data after user chooses a trip. User can select particular seats in real time with its interactive selection interface. During the booking process, the system momentarily locks certain seats to avoid double booking and preserve database integrity. In order to generate e-tickets, the service also handles passengers' profiling by gathering necessary information, including complete name, phone numbers, and email address. Lastly, we have back-end operator management service. This back-end helps transport operators manage their services. Operators can update schedules, routes, and seats layout. It also provides sales reports and passengers lists to support daily operation and decision making. Then, sustainability and future development. The system is designed to be easy to maintain and update. Clean code and good documentation help new developers and features Easybook can grow to include trains and ferries and update like automatic refunds without major changes. Lastly, quality assurance. Testing happens at every stage. Unit integration and system test check each part. Regression testing make sure new features don't break old ones. This keeps the system reliable and build user trust.
Warahmatullahi wabarakatuh. My name is Aisyah Maisara and I will talk about software process model that we choose, which is incremental development. Why did we choose? The model is flexible, which is easily to create and make changes from achieving feedback from the users. For each increment, only the requirements related to the specific functionality are defined in detail. Next is the model delivered in stages by releasing core functions such as user registration, route searching, and ticket booking early. User can begin using the system while other features are still developed. Each increment of the system undergoes through validation activities, including unit testing to verify individual components. Next is process activities. Process activities that includes 3, which are specification, development, and validation. I will say a little bit about the activities under specification. 1. Identify and prioritize core system requirements. Break down the system into functional increments. Then define detailed requirement only for the current increment. Under development. For under development, there are 3, which are design system components for the current increment, implement features using appropriate programming languages and frameworks, then integrate new functionality with previously developed increments. For under validation, we can conduct unit testing on individual components, then perform integration testing to ensure new features work with existing ones.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aidit bin Muhammad Maha. Today I'm answering the question 4C. For Easybook expansion into integrate bus, train, and ferry services, we have adopted the incremental development model. This allows us to involve the platform alongside market trends while ensuring each features is reversed before moving to the next. Our process begins with specification. We conduct feasibility studies for advanced filtering and gather detailed requirements directly from stakeholder surveys. This results in a formal SRS document covering everything from e-ticket generation to secure payments. Finally, we use prototyping to validate these requirements with users before a single line of final code is written. Next is design and implementation. We use a layer architecture, separating the user interface, business logic, and data layers to ensure the system reliability. Our design is modular with dedicated components for search, booking, and FPS payment integration. For data, we utilize a hybrid of MySQL and MongoDB to balance structure booking records with scalable trip data. To ensure quality, we perform 3 levels of testing. Component testing for individual modules, system testing for the full end-to-end user journey, and acceptance testing to ensure we meet the client's specific needs. But the project doesn't stop at launch. We prioritize evolution by adapting to business changes like merging ferry and train schedules and migrating to Flutter-based mobile platform for a seamless cross-platform experience. For conclusion, by following the incremental path, Easybook remains a flexible, user-centric, and technically sound platform. So now moving on to our project management, this Gantt chart outlines our execution plan. The project is scheduled to run from early April through late September, following the incremental phases we just discussed. From April to May, we begin with a high-intensity specification phase, covering feasibility requirements, elicitation, and validation to ensure our foundation is solid. From late May through July, we transition into heavy design work, including interface component and database design to prepare for the build. And for the August to late September, the final 2 months are dedicated strictly to quality assurance, moving sequentially through component, system, and final acceptance testing. So what is important to note here is the sequential dependency of each task. We ensure each increment is fully designed and validated before moving into the next testing phase. This minimizes risk and ensure a timely delivery by the end of September.
Over issue, poor project documentation. As a project manager, I see the biggest risk to project continuity as incomplete or inaccurate documentation during handovers. This includes decision log, technical specs, risk register, communication plans, and progress updates. If this information is missing or outdated, it can seriously slow down the project.
My name is Daniel Hazim and my role is a system analyst. As a system analyst for Easybook, my role is to gather requirements, analyze workflows, and ensure the system meets user needs. A key possible handover problem is incomplete or misinterpreted system. There might be some problem like updates from users and transport operators may not be fully documented. Sometimes changes are only discussed verbally and unclear in the final handover. For example, Easybook supports buses, ferries and trains, each with different refund rules. If these are not properly documented, the maintenance team may process refunds incorrectly, leading to user complaints and financial loss. There are some significant impact on the project, like system maintenance issues. Developers may struggle to fix or update the system without clear documentation because they depend on handover documents. Secondly, there is higher risk of errors. New developers may change modules without understanding, which could unintentionally affect bookings or e-ticket. Third is delays in future improvement. Future teams may spend extra time understanding the system, slowing down enhancements. This is because they need to reanalyze the system. In summary, as a system analyst, it is critical to ensure that all requirement modifications are fully recorded and communicated so the project benefits from incremental delivery and can evolve efficiently. Next, we're going to talk about the system architecture model.
Okay, now we're moving on to handover problem. Undocumented layered logic and API specification. As a programmer, my role is to maintain and scale our system using a layered architecture. However, we are currently operating in the dark because the existing code base acts as a black box. There is no technical documentation or API map to guide us. Development impact. While we use incremental development to roll out new ferry and train services, the lack of documentation makes safe system modification nearly impossible without a clear map of how modules interact. Every new feature carries a high risk of breaking existing functionality. We aren't just building, we're guessing. Why this occurred? The root cause lies in the handover process. Code was transferred without logic flowcharts, and system changes have historically relied on verbal feedback rather than formal technical requirements. This has left critical business rules, specifically for seat locking and e-ticket generation, undefined in our technical records. In conclusion, to move forward safely and efficiently, we must prioritize formalizing the specifications. We cannot scale a system we do not fully document. Thank you. Okay, now let's talk about how these handover issues actually hurt our project. As the programmer, the biggest problem I face is development stagnation. Instead of building cool new features, I have to spend all my time solving puzzles just to understand how the old code works. Losing our speed because the code is a mystery. We have reduced agility. We are supposed to be fast and move in small steps, but right now, every update feels slow and risky. We can move quickly if we are afraid that one small change might break the whole system. The risk of the company. Finally, this leads to competitive loss if we can't give our customers a smooth experience because we are stuck fixing undocumented bugs. Our competitor will move ahead of us. To get back on the track and start innovating again, we need to fix these documentation gaps.
Handover problem. As a tester, I choose the lack of detailed documentation from agile development. I think it the most disrupt because testing or this system evolution team expect a plan-based handover rather than agile development, which leads to confusion and delays during testing. Agile development helps Easybook release features more quickly. The lack of clear and detailed documentation during handover creates real challenges for testers. The impact of the project as a tester in Easybook, lacking of specific documentation, will mostly affect the project. Difficult for tester to know the expected behavior of the system, which can lead to error situations and special cases that been identified by users. Then, increase the chance of defect and delay from lack of interaction of making documentation with developers. Then, highly cost for a project when we examine features they already thought were finished but unfinished.
Next, we are going to talk about our system architecture model. Our group has choose the layered architecture, which has 4 layers. The first layer is the user interface. The second layer is the configuration services. The third layer is the website services, and the fourth layer is the utility services. There are some reasons why we choose this pattern. Firstly, it has clear separation of responsibilities and easy maintenance. Layered architecture separates the system into UI, application, and data layers, making Easybook easier to develop, test, and maintain. Changes in one layer do not affect others, which will reduce any errors. For example, changes to the user interface can be made without affecting the database or core application logic, thus reducing errors and improving system reliability. Secondly is flexibility, scalability, and external integration. Each layer can be scaled independently to handle high traffic. This supports Easybook large user base and allows easy integration with payment gateways and transport operators. During peak booking periods, the application can be scaled to handle higher user demand without modifying the user interface or database. This is suitable for Easybook, which must support many users and interact with multiple transport operators in real time. In addition, this architecture simplifies integration with external services such as payment gateways and transport operator systems, ensuring smooth and efficient operations.
Easybook project early user participation in testing. As the project manager for Easybook, my goal is to make sure the final platform meets user needs while keeping development on schedule. Using incremental development, we involve user in testing each increment to catch problem early and avoid costly fixes later. And for advantages or early testing, finding usability issue early. Increment 1 focuses on route searching and increment 2 on seat selection. By testing this early, we can see if the interface is easy to use. For example, a mobile user might find the seat selection confusing. Catching this now avoids expensive redesign later. The point number 2, checking business rules and real-world data. Early user feedback help verify rules like boarding procedures or peak hour pricing. For example, if a bus operator notices that seat availability isn't showing correctly, we can fix the database logic in increment 1. This prevents error from affecting later stages like payment or etiquette issues.
Next, we are going to talk about user involvement in early release testing. Me, as a system analyst for Easybook, my role is to ensure the system meets user requirements by working closely with users and developers. Involving users in early in release testing brings key benefits and challenges. There are some benefits and disadvantages involving user in early release testing. First, the benefits is they're going to have a better user experience. This is because early feedback helps identify unclear booking flows, navigation issues, and visibility problems, allowing improvements before release. Next is early issue detection. Real user testing uncover bugs such as payment or booking errors early, reducing rework and customer complaints. Disadvantages is more time and complexity. Managing users' feedback requires extra meeting and revision, which may delay deployment, especially for a complex system like Easybook.
For the user involving in testing, for the benefit ones, early detection of logic errors. Involving user early in release testing is crucially for catching deep-seated coding errors. When I monitor the backend, users often spot front-end failures such as fake computation errors or seats disappearing mid-reservation. By identifying these logical mistake and faulty module connection early, I can resolve them before they cause a major breakdowns in the production environment. For the second one is performance and reliability. User involvement allows me to observe the system under actual usage. It shows how the platform handles concurrent searches and bookings in real time. This feedback is vital for detecting bottlenecks in page loading times and server stability, allowing me to optimize my code and database operation for the smoother final release. Okay, now we're moving on to the disadvantage. The technical knowledge gap. However, this is a significant drawback. The lack of technical knowledge among users. During the validation stage, users often provide feedback based on personal preference or visual likes rather than reporting technical system errors. This makes it difficult for me to pinpoint the root cause of a bug, as I have to filter through subjective opinions to find the actual core system problems. In conclusion, while user involvement provides essential real-world data, it requires careful management to ensure we are solving technical flaws and not just catering to subjective tastes. Thank you for your time.
User involvement early in release testing for a tester. The benefits are early detection of usability issues that we can uncover workflow problems that tester may miss. Validation of business requirements and expectation that we implemented fetches with real user needs and expectation. As for this advantage for releasing testing, it may increase problem and potential on project delays. Users have different opinions and different expectations, which leads to conflicting feedback.